Hi, I'm Peter Haddock and I'm here with Alessandro, and he is the mobile mapping specialist here for Leica Geosystems, part of Hexagon. Alessandro, you've been a busy person because you've got a new Pegasus system here that's just been launched and just arrived in the UK, haven't you? Tell me a little bit about it. It's a lot smaller than its predecessor.
Absolutely, yes. We focused on usability on that system, and weight and size is part of it because we wanted that a single person can mount and operate the system. So you will see when I explain it further that it's not about only the handling, it's all about the workflows and the autonomy behind the new Pegasus TRK.
So the first thing I wanted to do, folks, I can't resist this, as I wanted to do the big movement with you, Alessandro, which is great. So first of all, I'm unscrewing this part of here. It's got safety built in, folks. Then we actually swing it round, right? Move your heads out, folks. Look, there we go to the actual back end of the machine. Tell me about this section that we're seeing right now.
Yeah, absolutely. What you see here is the Pegasus TRK 700 with the dual scanner configuration. On the back you already see the Smart Fusion laser scanner that is basically an hybrid module that allows you to collect SLAM data. So going inside GNSS denied area and still being able to have geo-reference data,
right,
like tunnel or indoors.
Okay. Well, what's really good about this phase, we talked about mounting the previous unit. Now we've got a whole nother element that we can do to actually pull this out, folks. So again, nice and simple. Look at this. I'm pulling it out. Oh, it's not heavy, folks. I'm just making a meal out of that. This allows us to then bring it down to this level. And of course, we see what those sensors were here. We've now got some more sensors. What's the one on top all about?
Exactly. We start with the camera system. So we see here a 360-degree panoramic camera with 24 megapixels that are in combination with, we call them butterfly side cameras.
Butterfly side cameras, I like it.
Exactly.
And then take it, these are those butterfly side cameras.
Exactly. So if we see here on the right side, we have the vertical position. So we are creating with the stereo camera a field of view of 105 degrees per 46. And on the other side, we can have the same. What happens is that you will have an arc of 210 degrees,
right,
with 13 times the higher level of details in the imagery part. So it allows you to see more details in a better quality.
So folks, you can see how easy it is to move down now off the roof rack. And that is a real fundamental to anything like this when you're mounting stuff safely, and obviously from a lifting point of view for an individual to work with this unit. It also makes it more accessible for using this system on different types of mobile equipment. So, you know, we're seeing here set up for a roof rack for a car, for example, but now we can use this sort of thing on, say, an ADT or something smaller, or even specialist smaller applications for rail, for example. It makes it all more compact, doesn't it?
Right, absolutely. And the real challenge here is when you go from a vehicle-based carrier platform like the car into the rail environment, your environment changes totally. So on rail you have suddenly shocks at the magnitude of 4G and vibration all the time given to the environment itself, to the carrier, and making a system lighter, smaller and more robust was one of our key focus on engineering when we developed the new Pegasus TRK.
So it's smaller and you've got the sensors and they've been upgraded as well from the previous system, but tell me, how much lighter is it from a unit perspective from the previous model?
Yeah, so we are talking here going down from 49 kilos to 18 kilos.
49 to 18,
right.
49 to 18 kilos. That is less than half, and fundamentally that is a massive difference. And size-wise, what are the proportions now that we've gone into?
In terms of a volume, we reached 40% of the previous one, while achieving also an environmental protection of IP67. So theoretically, you can go underwater with it.
You can go underwater with this. I'm just about to try and find my one flying car. There's a new flying car airport down the road in Coventry where I live. But two, I want a flying submarine type car so I can just take this all over the place with me. So fundamentally, what we've got is a new solution that can be in all weather applications. You can actually utilize it to do a lot more than it did before, and you can mount it in different places and spaces.
Absolutely. But the real innovation comes with the software. So now we integrated autonomous, intelligent, and simplified workflows that makes this huge step forward in terms of technology and accuracy accessible to more people. So having all the various steps simplified and automated makes mobile mapping now accessible to novices, and is not only a tool for experts like nowadays used to be, right?
Right, fantastic. So what we're really seeing here is a revolution in mobile mapping. That's what we're saying. We've got a solution here that's more accessible to different places, different spaces. You've got all the software support for it. I'm going to have to go out and see this on the road myself, folks, and I'm certainly going to ask the team here if I can do that. But until now, we've got to put this back in its place, because there's plenty more people that want to be looking at this. It's the highlight of the show, isn't it?
It is, yeah. It surely is. And it's not only about the show itself, it's really the team that committed since several years. We are developing since 4 years that system to really achieve a fit and finish and an accuracy that was not thinkable 5 years ago.
So it's a big project, but it's not a big device anymore, folks. I'm going to put it back, and thanks very much for talking to me today.